All right, so with polar coordinates, what we want to do here is we have to find the radius and the angle for our vector to reach to terminate at point B right there. And so what we're doing here is we started our initial position here. And so our angle is just how far are we rotating around to get there, and then r is that distance. And sometimes r can be negative, and if it's negative, you just go in the opposite distance once you get to your angle. If the r value is negative, then you actually just flip around and do a 180. So on this first one, though, our r value is positive and our angle is positive within that single rotation. And so the way the polar coordinates are set up, it should be kind of similar to your unit circle. It starts out here, I believe. Let's see. So this would be pi over 6. And then if I go another 2, this would be pi over 3. And then let's see. If we go another one, then this would be pi over 2 and so on. So it's pretty similar to your unit circle. Let's see, this would be pi over 4 right there. And so these ones on the fringes right here are between the axes and that first angle or the last angle of that quadrant. You can kind of not really worry too much about those. I mean, you might have to use those sometimes, and we'll just have to do a little bit of math to figure out those angles. But this one should be fairly simple. So as you rotate around, oops, as we rotate around, here we go. So pi and then 3 pi over 2 and then one more click here. And if you were to look on your unit circle, this would be at 5 pi over 3. So I'm going to go ahead and list that here. So, and then we'll list our radius. So let's see, this is going to be 5 pi over 3. And then the radius, so our distance from the center would be 1 click, 2 click, 3 click, 4 clicks. And so that is our coordinate for the point B right there with those parameters. Now, the part 2, this time we're going to have a negative radius and we're going to have another positive angle, but it's not going to be the same angle, because what happens is with this next one, our angle, what we're going to do is we'll kind of rotate around, but then since our radius is negative, what happens is you flip across. So if it's a negative radius, it just reflects across the origin right there. So right here, to reflect across there, let's see, where would that take me? It would take me to here, I guess, right? So I need to figure out the angle for that right there. And so I believe, let's see, if that should be a 6 of a pi plus a half of a pi. So let's see, that'd be 4, 6 reduced would be, let's see, 2/3 pi. Oops. Let's see. So my angle would be 2/3 pi. That's what this angle is right here that I'm getting right here. Okay. But then I'm going to use a -4 for my radius. And so what that does is it causes this to reflect across. And right there, I landed on the point B. Okay, now for our next two, the parameters, they kind of switch it up on our angles. They want us to look at an angle from -2 pi to 0. So instead this time, what we're going to do is we'll start in our same position right here, but then we're going to rotate backwards. So this would be in a negative direction from 0 to -2 pi going around this way. And then our R value is going to be positive. So since it's positive, I want to rotate here and I want it to stay here. I want it to be right there. So let's see, how far did I rotate? So I'm going in the negative direction. So let's see, if this was 1, 2, 3, 4 clicks to get to positive pi over 3, if I go 4 clicks the opposite direction, that angle would be negative pi over 3. So that's going to be my angle, negative pi over 3. And then my radius, since I'm going from my origin directly out to it, that would be a positive 4. Now for part D, we're going to basically do the same thing, except that I'm going to, my parameters state that I want my radius to be negative. So instead of just rotating here, What I'm actually going to do is I'm going to rotate all the way around here and then reflect across over to here. That's what the -4 will do for me for my radius, since my radius this time has to be a negative. So I know my radius is -4. So now I just have to figure out what rotation from the from my initial starting point will swing me around here, but then keep going another half a turn basically, and then that -4 causes me to reflect across and end up right there. So basically it's an extra pi rotation. So if you just add pi to this right here, well, negative pi, because you're going in the negative direction. So let's see, we have negative pi over 3. We're basically just going to add another negative pi, because that will rotate me around a half a turn exactly, and then I reflect back across because of my radius being negative. So I need to get an LCD. So let's see, we'll have negative pi over 3 plus -3 pi over 3. We add that together, we get -4 pi over 3, and that will be my angle for that one. Okay, the next one should be pretty identical, but we'll go ahead and go over that just so we can get some extra practice. Okay, so they kind of move the B, my point over here, and it looks like it's 1, 2, 3, 4, 5 clicks. So my radius either has to be a 5 or a -5, and then depending on the parameters. And then also we're looking at angle rotations going counterclockwise and then clockwise. And so the first ones we'll look at are the counterclockwise, our positive angles. So R is going to be positive, and my angle is going to be positive too. So let's see, we'll go ahead and make a little vector here, and we're going to rotate it around. Oops. Let's see if I can grab that endpoint. There we go. So we rotate around, and so there's a pi right there, and then I go an extra click right there. Okay. So once again, if you kind of look at your unit circle, the way it's kind of set up is, let's see, this would be pi over 6. This would be pi over 3, and then we'd have pi over 4 in the middle, and then this would be pi over 2. This would be a pi right there. But anyways, you can kind of see that every 2 clicks or whatever as you're rotating around is worth pi over 6. So this would be 7 pi, oops, 7 pi over 6 right there. 7 pi over 6, because I'm adding an extra pi over 6 to rotate to this position. So let's see, my radius, what did we say, it was 5, right? 1, 2, 3, 4, 5. And then I'd have to rotate 7 pi over 6. Okay, now my other one, I'm going to have a negative radius, okay? And so this time I'm actually going to rotate 180 degrees less. I'm going to rotate to the right. Is this going to right for me? Let's see. I'm going to rotate. There we go. I'm basically going to go, let's see, 1, 2, 3, 4, 5. Perfect. I'm basically going to rotate to this position right here. So my initial position is always the x-axis right here. Right there, that's always my initial position. So I'm actually only going to rotate pi over 6, but then I'm going to do a radius of -5, which causes me to go in the opposite direction of the origin right there, and my landing spot will be right where I want to be, right there at B. So this time, let's see, my radius is -5, and my rotation from my initial position will be pi over 6. And then the last two, just like the other ones, we're going to look at going counterclockwise on our rotations. And the first one, we're going to have a positive radius value. So on that, we're going to be rotating from here to there. So we're going to get a negative rotation right there. Well, there's a couple of different ways you can figure it out. You might be able to even do it in your head. So if you think about this, let's see, there's a couple of different ways you can approach this, but let's see, this is pi over 6, pi over 3, pi over 2. This would be, let's see, if we do another 6, let's see, that would be 3 pi over, let me double check that. This would be, yeah, 2/3 pi, and then if we go, let's see, if we go again, let's see, that takes us to pi. Let's see if we go here, if we just do another 1/6, or if you take one off, let's see, that should be 5 pi over 6 right here. Okay, so the reason I did that is because this would be a positive rotation of 5 pi over 6. And this is the same rotation, just in the opposite direction. So this right here would be negative 5 pi over 6 if I were to kind of rotate backwards. There's other ways you could have figured that out, but to me, sometimes it's easy just to find that positive rotation and then look at the opposite rotation of that, and then it's just going to be negative. So let's see. So the R value is positive, so we're going to want to put that as a 5. And then my rotation, I'm going in the clockwise direction. So it's going to be negative 5 pi over 6. And then the last one, you can see right here, once again, we're going to go in the clockwise direction. And then my radius is going to be negative. So I know it's going to have to be negative 5. And so basically, see, I want to get to this point right here. I need to get there rotating in this direction, though. So I'm going to go here. I'm actually going to keep going, though, an extra 180 degrees, or basically an extra pi, right, in my negative rotation direction. And then that negative 5 is going to cause me to go the opposite direction, and then I'll land exactly where I want to be. So basically, I need to rotate in the negative direction an extra pi. And so I did this on the previous slide, and we can do it here also. So I have negative 5 pi over 6. That'll get me to this point right here. But the problem is the radius is negative, so I would go out the opposite direction. So I need to rotate another half rotation, or a pi. That's a pi. So I'm going to add a negative pi to that. And then I just have to get my LCD. So we're going to have negative 5 pi over 6 plus negative 6 pi over 6. When we add that, we're going to get negative 11 pi over 6. And that will be my angle right there. And so that angle right there will whip me all the way around to this red line right here. And then since the radius is negative, I don't actually go out this direction. I go the opposite direction. I go backwards, and I will land right there at the B position. All right, I hope that kind of helps you out a little bit, but if you've got more questions, just go ahead and send them.